All right. GCF and LCM. So what does the GCF and LCM stand for? GCF stands for greatest common factor. So this should make sense as to why we are doing it in this section. And really we're looking off of, if you can find the factors, then you're going to be able to find the GCF, the greatest common factor. So we're going to find the factors for 10 and we're going to find the factors for 14. So if we're going to move quick through this just because, well, I'll put it this way. I'm going to move quick through finding the factors because that is from an earlier video. So if you need to slow down, you can stop, you can kind of rewind, or you can go back to the video on finding factors, which is 2 back, or maybe 3 back. We will slow it down when we're actually looking for the greatest common factor, which is the new section from this week. So factors of 10, we're going to grab 1 and 10, 2 and 5. Factors of 14, 1 and 14, 2 and 7. Greatest factor that's common between them, well, let's look at all the factors that are common between them. We have 1, we have 2, and that's it. 5 is not common between them, 10 is not common between them, 7 is not common between them, 14 is not common between them. The greatest common factor that they have is 2. So that is our answer. Okay? And that is it. All right? So, GCF of 12 and 30. 1 and 12, 2 and 6, 3 and 4, 4 and 3, so I know I'm done. 1 and 30, 2 and 15, 3 and 10, 5 and 6, 6 and 5, so I know I'm done there. Looking for common factors, again, so I'm just going based off of now. 1 is always going to be a common factor, but it's important that I grab it because it could be my GCF. So 1 is a common factor, and it will always be a common factor. 2 will always be a common factor if they're both even numbers. 3 is a common factor here. It will sometimes be like left to right. So if you look like these just happen to be lining up nicely, but that doesn't always have to happen. I don't see 4 on both lists, 5, 10, 12, 15, 30. So the greatest common factor is 6, and I'm all done. All right, same thing when I have multiple, and again, you're going to start seeing some that are, the same and you've done them. So, you can just copy your list, you can use them again. You don't necessarily, don't do work twice. So we have 15, 30, and 105. So for 15, I have 1 and 15, 3 and 5, 5 and 3, but that's done. For 30, I think that's one of the ones that I've done before. Okay, and 105. So this one, I don't know them all off the top of my head. 1 times 105. 2 is not 1. 3 is 1. 3 is 35. 5 is 21. 6 doesn't work. 7 doesn't work. 7 does work. Oops. 8. 9. 10 doesn't work. 11 doesn't work. 12. 15 does work. And that one's my repeat, so I'm done. Okay. 6. Okay. So if I'm looking for common ones, 1. Now, to be a GCF of 3, it has to be common between all 3 of them. So, like 3 is common because I have it in all 3 of them. 5 is common, and here's where I mean, like, it's on the right here, it's on the left here, it's on the left here. But that works. All right, and 15. And I'm actually all out of factors on 15, so I can pretty much stop looking. And if I look for my GCF, my biggest one or my greatest one is 15. And I'm all done. And factors, greatest common factor has to be within. It can't be bigger than any of the numbers because you're looking for factors which are smaller. Factors are a piece of the number, so it has to be smaller than the smallest of the numbers. All right, 10, 15, 25. So 10 is 1 and 10, 2 and 5. It would be 5 and 2, but that's done. 1 and 15, 3 and 5. 1 and 25, 5 and 5. And again, remember we talked about that. That's that perfect square. When you get the same number twice, you know you're done. So again, looking for common, we have 1 all the way across. We have 2 does not work. 3, no. And 5, yes. So my GCF is a 5. All right, and oops. My LCM. My LCM stands, whoops, for least common multiple. And if you think about it, factors are within because you're finding pieces of the numbers, whereas multiples you're multiplying, so it should be a bigger number than either of the ones, either or however many, it could be more than 2, any of the numbers that you are choosing from. So if you want to note that least common multiple will be bigger, GCF or greatest common factor will be smaller, just something of note. So what you're going to do is this. You're going to, all right, so LCM is a little bit more complicated to figure out. It's just a couple more steps. So the first thing we're going to do is we're going to make the factor trees. So you start with the factor trees. All right, so you have to make 2. So here we do 8. So we're going to break down 8, 2 and 4, circle the 2, 2 and 2, 2 and 2. Okay, and then we do the 12. So we get 2 and 6, circle the 2, 2 and 3, oops, 3, circle the 2 and the 3. Okay, so what we want to do is we want to create pairs. Okay, so here's a pair, here's a pair, and we have no more pairs. So basically we want to couple off who we can couple off, and then we want the singletons to hang out with the couples. So this green couple is going to come down. Okay, this blue couple is going to come down. This single is going to come down. This yellow single is going to come down. And then you're going to end up multiplying them all together. So when you do this, it's important that the couples only get counted as a couple, and the singles only get counted as a single. So a couple, you know, it's like as if, you know, like you can buy a couple's ticket to the dance or you can buy a singles ticket to the dance. The couple's ticket usually, you know, you get like a little discount. Like you wouldn't buy two singles tickets. You would buy, you know, almost like, oh, a singles ticket costs $20 each, but a couple's ticket costs $35. So you wouldn't buy two singles tickets for the cost of $40. You'd get a $5 discount, kind of something like that. Kind of that kind, you know, that kind of example. That's what you want to almost think about when you're doing this. So what I mean by that in mathematical terms here is this. These twos come down as one couple. These blue twos come down as another couple. This single two comes down as a two, and this single three comes down as a three. So this is a couple, this is a couple, this is a single, this is a single. 2 times 2 times 2 times 3 gives you, 2 times 2 is 4, times 2 gives you 8, times 3 gives you 24. Now, why is this? Like, what is the LCM actually doing? Well, the LCM says this. You know, a real-world application problem to this is something like, you know, your skip counting. So every 8th day or every 8th house, somebody knocks on the door, and then every 12th house, somebody else knocks on the door. How many doors so how many of the same doors do the two people knock on? So, you know, person 1 knocks on the 8th door, the 16th door, the 24th door, the 32nd door, the 40th door, the 48th door, the 56th door, and on and on and on. The second person knocks on the 12th door, the 24th door, the 36th door, the 48th door, the 60th door, the 72nd door, and on and on and on. So you see, like, the first door they knock on that's the same would be the 24th door. And you see that that's true because we found our LCM, our least common multiple, the first time they match up to be 24. Now, it's true that it would happen every 24th door or every 24th day. Now, if that's true, the next time it would happen would be on the 48th door. And we did find that to be true because I kept going with my skip counting. So you see that that is true. But basically, this is not always going to be a realistic way to do it because if your numbers aren't nice, if your numbers are really big, if you have multiple numbers or more than 2 numbers, that's not going to be a realistic way to do it. So we want a different way to do it, and that is this way. So let's start again. You want to factor tree it. So, oops, not highlighter. So if I factor tree 5, well, that's just 1 and 5. And again, I told you usually don't want to use ones, but in this case, you don't have any other numbers to use. So 1 and 5, because this is a prime number. And then 9, you're going to do 3 and 3. They're both prime. And then, again, you're looking for pairs. Well, you don't have any pairs. These don't have anything in common. So here's a case where you have all singles, right? Everything's a single. So everything is a single. Coming down. And when I do that, I get 1 times 5 times 3 times 3. And again, why can't these partner? Why can't these pair up? You may be saying like, well, wait a minute, the same number paired on this side, they don't pair because they're from the same number. In order to pair, one would have to come from the 5, another would have to come from the 9. These are both coming from the 9, so they can't pair. Okay, so 1 times 5 times 3 times 3 gives me 5 times 3 is 15 times 3 gives me 45. Let's just see if that's right. 5, because these are small enough numbers. 15, 20, 25, 30, 35, 40, 45, 9, 18, 27, 36, 45. There's my 45 and my 45, so I'm good to go. All right, so now I have 3 numbers. So I have 3, factor tree, 1 and 3, 5, whoops, 1 and 5, 6, I don't know why I keep underlining it, 2 and 3. Okay, in order for it to be partners, in this case it has to be triplets, right? It has to be across the board, there for everything, common with everything. I don't have that. In this case, my closest one was the 3. It was there and there, or the 1. 1 technically could be, because I could break this into, I could say it was 1 and 6, but that doesn't really help me. So really it's all of these numbers, right? 1, 2, 3, 4, 5, 6. 1, 3, 1, 5, 2, 3, all multiplied by each other. 1 times 3 is 3, times 1 is 3, times 5 is 15, times 2 is 30, times 3 is 90. Okay, you could very easily do the same thing we did up there, but it's going to be a little bit more painful because, 3, 6, 9, writing that all the way out to 90 really is going to take up some of your time. And again, you want to work smarter, not harder, and you want to, you want to use your time efficiently, especially on these timed quizzes. All right, let's do this one. 8, 24, 56. So 8, we have 2 and 4, circle the 2. 2 and 2, circle both 2's. 24, we have 2 and 12, circle the 2. 2 and 6, circle the 2. 2 and 3, circle the 2 and the 3. 56, we have 2 and 28, circle the 2. 2 and 14, circle the 2. 2 and 7, circle the 2 and the 7. All right, so common things. We have 2, 2, 2. We have 2, 2, 2. We have 2, 2, 2. So we have couple, 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 single, single, right? Couple, 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 single, single. So we have 2 times 2 times 2 times 3 times 7. So 2 times 2 is 4, times 2 is 8. 8 times 7 is 56. 56 times 3, 18, 15, 16, 168. All right, let's go to the last page. All right, the word problem with this, you're just going to have to get through the words to get the numbers, and then you're going to be able to do the same thing. I mean, I think that goes for along with every word problem, but these, really what I mean by it is they're pretty straightforward in that it's really just the words are hiding the numbers. Don't let them throw you. Don't let them complicate it. A gym that's open every day of the week offers aerobics class every third day, and Tai Chi classes every fourth day. So really, there's the 3, there's the 4, okay? These are your 2 numbers. A student took both classes this morning, so they're saying that it happened today, the same day. In how many days will the gym offer both classes again on the same day? This is LCM. This is asking you for the least common multiple because they want to know it's happening the same day, right? They're asking you, when is it going to be in common? So 3 and 4. Well, you do your factor trees. 3 is 1 and 3. 4 is 2 and 2. What's common? Nothing. So we have 1 times 3 times 2 times 2. 1 times 3 is 3, times 2 is 6, times 2 is 12. So in 12 days. So the classes will happen on the same day again in 12 days. Okay? A family must budget for life insurance premiums every 12 months. Car insurance premiums every 3 months, and payments for a home security every 5 months. If all these bills were due this month, in how many months again will they fall due? So again, LCM, because they're asking for a common month. So we have 12, we have 3, we have 5. So 12, we have 2 and 6, circle the 2. 2 and 3, circle the 2 and the 3. 3, we have 1 and 3. 5, we have 1 and 5. We have nothing common across the board, so we are multiplying all these together. 2, 2, 3, 1, 3, 1, 5. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 1 is 36, times 5 is 180. So 180 months. It asked me for months, so I don't have to change it. So they will all be due again in 180 months. If you wanted to convert that to years, it would be 15 years. So not terrible. You get 15 years before they're all due again. All right, so that's it for the week. Let me know if you have any questions, and I will see you on Tuesday.